Here's a solution for day 3, problem 1. Find all real zeros of this function. Zeros are the values of x that make the function turn out to equal 0. So we could rewrite this as 5x squared plus 15x equals 0. And solve this for x. That'll tell us what numbers we could input for x so that function f turns out to have a value of 0. Let's try factoring method. There is a greatest common factor that divides into both terms. It is 5x. For the other factor, we need to have an x because 5x times x is the 5x squared. And then we have to have plus 3 because 5x times 3 is the 15x. And that's equal to 0. Now let's use the zero product property to find answers for x. The first factor is 5x. Maybe that's the one that equals to 0. Or the second factor is the x plus 3. Maybe that's the one that equals to 0. Solving the first one, we get x equals 0. Or, in solving the second equation, we get x equals negative 3. These are the two values for x that, if inputted into the function, would make the function have a value of 0. Therefore, these are called zeros of the function. Day 3, problem 2. Sketch the graph of f of x equals log base 5 of x. Here's the x-axis, and here's the y-axis, which in this problem is called the f of x axis. We're using f of x instead of the letter y. But we're still going to graph this function by finding points and then drawing a line through them. Logs are related to exponents, and you find the values of logs by asking yourself what exponent is needed to create a particular number. So let's substitute numbers for x and then evaluate the log to find the corresponding f value. One number that's a good one to try for x is 1, because when we take the base 5, we can ask ourselves the question, 5 to what power makes 1? And the answer is 0. 5 to the 0 power is 1. So when x is 1, the function value turns out to be 0. 1 comma 0 is located right there. Now, when the base is 5, another good number to use for x is 5, because we can take the base 5 and ask ourselves, 5 to what power makes 5? 5 to the first power makes 5. So when x is 5, this function turns out to be 1. 5 comma 1 is a dot on the graph. Now another good number to use for x is 25. 5 to what power is 25? And that power would be 2. So if x was 25, this function turns out to be 2. 25 comma 2 is on the graph. But notice that the x-axis only goes to 10. It doesn't stretch far enough over to go to 25. Logarithms never create 0 or negative numbers. And so when we draw in the graph for this, we want to squeeze close to the y-axis, go through that point that we located, and swing over here, going through that point. Remember, we're now headed on our way towards the point 25 comma 2. It's just going to go off the side of the grid. When you squeeze up close to a line, that line is called an asymptote line. In this case, the asymptote is the y-axis. So here is our graph of this logarithmic function.